Hi everyone, welcome to my YouTube channel Understood. I am Ben Suresh. So today in this video we are going to the part 3 of thermodynamics. So come, let's get started. So in the before video we have seen that the properties of system is nothing but the physical characteristics of the system. For example, pressure, volume, temperature, etc. So the physical characteristics of the system, what we name it as, which is called as properties of system. So next we have seen this till here, and next let's move on to the next one, which is now consider a system. So in system we can see that the properties of system, there may be variations are there. Normally in any system if you see that there are chances of variations are there. So based on property variations, so some systems will have a definite value of properties. So the properties of a system will have definite values, and in case for some systems the properties will vary, and what from one state to another, that we will be discussing later in the discussing in the coming sections. So on based on property variations, it has, so the from one certain definite values it changes to another certain definite values of properties. So for all that we have each terms such as state, process, path, like that there are many terms, and these terms you would have seen in your earlier classes. When you say when you see in your science books, you can see that. So you will be familiar with this. Okay, so let's move on to the first one, which is state. So state is nothing but when the properties of a system, see as I say, when the properties of a system have definite values, that means that the system exists in a definite state. That's all. That's simple. Now consider this graph. So this is the PV graph. Here the P stands for pressure, V stands for volume. So in this PV graph we can see that. So here I have marked the position of the system. So system is here. So at this point we have the pressure has a definite value, temperature has a definite value, volume also has a definite value. So all this for understanding purpose I have shown you a pressure volume graph. So here the state we have marked. At this point we have definite values. So when the properties of a system have definite values, when these properties of system have definite values, then that system, here I am marking, then the system exists in a definite state. So this system now it exists in a definite state as it have definite values for its properties. So that's simple, right? So let's move on to the next one, that is change of state. So change of state is nothing but when the values of properties changes from one value to another, that we call it as change of state. Now see this PV diagram. So in this PV diagram we can see that here pressure volume diagram. So here the system, this system is in state 1. In state 1 the system has definite values for pressure, temperature, pressure, volume. It has definite values. Now after due to the surrounding factors, this now consider that due to surrounding factors, it the values of definite the values have changed of pressure, volume, it has changed, and it has reached here. Same system, from here it has reached here. So when that values of properties changes from one value to another, from one definite values of properties to another definite values of properties, that we call it as change of state. So when the system went state from state 1 to state 2, that is called as change of state. That means the values of properties changes. So this is what we call change of state. So next one, let's move on to another one, which is path of change of state. As we are moving on in this, we can see that we will be understanding what I mean. So in path of change of state is nothing but succession. Here the succession here, it will 2c will be coming here. So I'm really very sorry, extremely sorry, as while writing fastly I did a mistake in spellings. So here also changes, so there's a small spelling mistake. I'm extremely sorry. Next time I'll try to correct it. Okay, so what is path of change of state? So path of change of state is nothing but succession of states passed through during a change of states. So succession of states, so we can see the graph so that you will understand. So succession of state, what is succession? Succession, normally while you see in any dictionary you can see that succession is nothing but a number of things of similar kind followed one after the another. That means a number in this you can see that now in this PV diagram, now from state 1 to state 2, values of properties have changed from state 1 to state 2. So this is called as change of state. As this change state has changes, change of state takes place. Now here then what we mean as path of change state, it is known as succession of states. So succession of states is nothing but at each point here here now consider this way. In this way, at each point the properties are changing. At this time you can see that the graph is marked in this way. At this point you can see that the graph is marked in this way. Here at each point the properties changes. So succession of states passed through during change of states. So succession of states, so number of things of similar kind follow one another. So in this similarly changes at one point. So succession of states pass through during, so pass means it's passed through during a change of state, that we call it as path of change of state. So the path can be of different path. It can be of this path or this path. So it may vary based on the process which you have mentioned. So this path you will be understanding it further while seeing another term which is called as process. Process is nothing but when the path is completely specified. That change of state which we call it as process. So I hope you have understood. Now for example, I will show you a graph. Constant volume process is an example of process. Now see here in constant volume process, you can see that here in the PV diagram the volume is in x-axis, so it does not change in this direction. So in constant volume process the volume is always fixed. Yes, it means that it's fixed, only the pressure changes, so it moves in this direction. So you can see that the path is not changing this direction or this direction. It's not moving in it. It is at one specific path is given for that process. So as path as a succession of states pass through during change of states. So it has a specific path. That as it has a specific path, so that one which we call it as process. So when it has a specific path, that change of state is called as process. Example is constant volume process. Okay. Specific. Next is cycle. So moving on, you will understand the terms one by one. Okay. Now cycle. What is cycle? Cycle is nothing but change of states are taking place. As I mentioned before, change of states. That change of states are in series. N number of times the change of states can take place in the cycle, but the condition is that the final state should be identical to the initial state. So for example, you can see Otto cycle, diesel cycle and Rankine cycle. These are the examples. So while seeing the graph you will understand it. Now in this graph you can see that there are two constant volume process, two adiabatic process. So this name of process you will be learning, you will be seeing it in the upcoming you will be seeing the graphs like this. So here this is a pressure volume graph. So here from state 1 to state 2 the same system passes from state 1 to state 2 and from state 2 to state 3 and from state 3 to state 4 and again from state 4 to state 1. So 1, 2, 3, 4. So 4 times the state is being changed. Change of states has taken place 4 times. That they mean as a series. Series means n number of times. Here we are considering n is equal to, what is the value of n? N is equal to 4. 4 times change of state is taking place. So in one cycle 4 times the change of state is taking place. So after one cycle the what they have said, the condition is nothing but the final state which we get after a whole cycle should be identical to the initial state. That is nothing but it is coming back to the same position which we have started. That is nothing but it is called as a cycle. So what is cycle? Cycle is nothing but a series of change of states such that the final value of the state is final state is identical to the initial state. That is called as cycle. Okay. So let's next is we are going to discuss on the types of properties. Types of properties are of two types: intensive properties and extensive properties. So this one you will be seeing it in the next video which I am going to post. Okay. So I hope everyone would have understood. See, a normal property which you have seen, from that property some variations are taking place. So based on that variation they are given the terms. So these terms you have seen it before, right? So now I hope you have had a clear cut idea. Okay, so these were the terms which we seen in our earlier classes, and now we are very familiar and you are very thorough in that. So I hope you have understood this video. So make sure to like and share and subscribe, and also share to your friends, those who are in need of any help. Okay, so I hope you have found this helpful, and this is Ben Suresh signing off. So everyone, see you again. Bye bye.